right. Hi, everybody. Welcome to Test and Measurements, week, 5, maybe. Okay, so chapter 15, Truth and Justice for All. So you'll see as I go through this brief lecture that there are sections that come up. This is just the way that I thematically separated the chapter. So first, we're going to talk about test bias and test fairness. So what is test bias? It is a specific statistical meaning, right? So test scores systematically vary across different groups because of something completely unrelated to what we're trying to measure, right? So we're looking at that difference. Now, difference does not prove bias, right? We also have to determine whether that test is measuring what we intended to measure. And there's the two-prong rule, but to make it a little bit easier, I give you an example here. So if boys and girls in 11th grade actually differ in physical grip, remember that test you used to have to take in PE, either the hang test or the pull-up test. So if you give a test to 11th grade boys and girls and you find that they differ, well, that's valid because that's a reflection of real life, right? The strength is different in 11th grade boys and 11th grade girls. We know that. So that test is not biased. That's just different. Now, if these 11th grade boys and girls are equal in math and their ability for solving math problems, but you give them a test that has Broadway musical themed questions, well, that's going to create a difference. And therefore, that math test is then biased, right? Because 11th grade boys know way more about Broadway musicals than 11th grade girls. So let's look at the difference then between, is it biased or is it fair, right? When we think of fairness, it's a much broader concept than biased, right? They're related, but different concepts. So fairness is the extent to which a test works equally well for each person that's given it. So bias is a statistical question. Fairness is an ethical question involving how tests are used and how they're interpreted. Okay. So question, is a test fair if everyone receives exactly the same test? Well, no, fairness isn't giving everyone the exact same test. It's ensuring everyone has equal opportunity to demonstrate the trait that's being measured, right? So this is where accommodations come in order to increase the fairness rather than reduce it. So I have two scenarios for you here. I want to go over and you tell me, is it biased or is it unfair or is it neither? So first one, going back to the physical strength assessment. So we give an assessment to both men and women to assess their physical strength, right? And men are going to score higher on average than women. So is that test creating a biased environment? Is it a biased test? No. Is it unfair? No, right? Because if the test is measuring physical strength and the real average strength differences already exist, then the score difference is then not evidence of bias, right? Because differences do not automatically equal bias. Remember that, okay? And differences do not always equal discrimination. Next scenario, we have a math test, and it contains sports statistics terminology about the success, the overwhelming success of the Michigan Wolverines, which is unfamiliar to some students that are taking this test, right? So is this test biased, unfair, or neither? Well, it's biased. So the test is supposed to be measuring math ability. Now we're adding in a sports knowledge question, which is an irrelevant construct. So even if students with equal math ability perform differently here, it's likely because of the sports familiarity, which creates that test bias. All right, so what do we do about it? Well, along came this fair test movement, and it challenged this over-reliance on standardized testing. I myself do not love standardized testing. It creates an environment where teachers have to teach to the assessment. Okay, so what they said was that assessments should be fair and valid. They should be open, meaning transparent. They should be used appropriately. Evaluations should be done with multiple different sources of evidence or multiple tests over time. And then no single test should determine someone's future. So alternative tests should be used also in the assessment. So section 2, we're going to move from defining what is bias to how do we detect bias. So researchers have statistical methods to determine whether this bias exists, and they've come up with some ideas. So the first one is the difference bias. The model basically asserts that two groups differ on an average score, then the test is automatically biased, right? However, that assumption is flawed. So gaps in the scores can reflect real world differences, okay? So again, we have to investigate the difference before saying, yes, it's a biased test. So an example, if an international student struggles on an achievement test, performance differences might reflect English language limits rather than their actual mathematical skills, right? The test measures language in that case and not math. Another way to do this is to look at items item by item, right? If you remember the item response theory, we're looking at item by item. So differential item functioning, right? That looks at the individual test items. Students with equal overall ability, we would expect them to perform similarly on individual items. If they don't, that item may be biased, right? So for example, for me, the way that I apply this differential item functioning is when I give you an assessment, I don't just look at your grades, I go in and look at the behind the scenes data that shows me how each student performed on that question. And so if I see that, 50% of the students did not get that question, then to me, there's some issue, right? Maybe it was a biased question, or maybe it wasn't written the right way. Regardless, we weren't measuring the construct there. So I'll fix that. So why does it matter? DIF acts as an empirical, meaning like grounded in lit, microscope. It removes the excuse that group differences are simply due to overall ability, exposing biased language at the single sentence level. Then we have the on the face of things model. So here we're talking about content validity. Remember that? And so here we're looking again at the specific items rather than overall scores. And we're looking to see, is there any item biased, right? Biased items can misrepresent groups based on race or ethnicity or age or gender. For example, illustrations only showing white individuals or stereotypical gender roles may make some test takers feel excluded. So we look for that, right? And then we review the bias. So test developers are going to look at, they have expert panels that identify any potentially biased questions, and then they either revise them, remove them, or continue to evaluate them. So that's the on the face of things model. And then you have the Cleary model, which was created a long time ago, 1968, back in the 1900s. And it says bias is a test measuring different things for different groups, okay? And so it uses regression analyses to determine whether a test is then predicting outcomes equally well across all groups that it's using. But the key idea is if a test is unbiased, then people with the same score should perform similarly on an external criterion, right? Regardless of group membership. So for example, the SAT scores predicting college performance equally across all racial groups, right? That would be an example. All right, and last but not least, the playing fair model. And so it's the idea, this concept is that bias is often unintentional, right? So test developers have to actively check their assumptions, right? So there's a 4-step procedure. Recognize own biases and stereotypes, their assumptions. Get a second opinion. When in doubt, start over and ask for help. And then understand that all test takers are different. So here's a video on exploring bias, the implicit bias, peanut butter, jelly, and racism. And I'll put the link for you, and I want you to watch it. And so as you're watching it, I want you to just think of some examples of assumptions that influence our judgment. And I'll put that link in your module so that you can watch it. That way it's not playing during this and throwing you off a little bit. But that's what that's for. So the next section, we have section 3, which is on universal design. So now instead of detecting bias after a test is created, universal design is going to prevent any of those barriers in the first place, right? Because the goal is accessibility for all test takers. So universal design, right, is a less obvious way to think about fairness. So it's the question of whether a test works for everyone, right? So for instance, if one person may have a higher vocabulary and be more comfortable with multiple choice formats, then the test is then more valid for that person. Differences in traits affect the scores. So when there's a difference between students of the same class, and these differences are all characteristics that are not related to the construct of what you're testing, then that construct is the one measured by the test. So such differences there in that measured trait across students are going to affect the score, but those differences should be the only thing affecting the score. So ultimately, universal design like Universal Studios or Universal Remote has a solution that if we build a test that does a good job of measuring the specific construct and only the construct that works equally well for every person in the universe, then we can make a fair test. Right? So a metaphor to help with this is a ramp, right? So a universal design, structural ramps, they serve as a benefit to all users, right? They benefit more than just people who use wheelchairs. And so similarly, universal design testing works the same way. Good design helps people perform at their best. So this slide is about in the 1960s when the accessibility movement began. The public government started it just with government buildings. They wanted to make sure that everyone had access to government buildings. So they began redesigning them, including wheelchair ramps and elevators and fewer doorknobs and changing the bathrooms, etc. So like all good ideas, within a few decades, the concept had expanded to all buildings and all housing. So similarly, equal tests, accessibility in tests, slowly the idea went from just one small space to a much larger. Everyone is expected to have tests that are equally accessible and measure what they're intended to measure. So some of the rules, right, to help with making a universal design test, they have some mechanical rules, right? So margins, they say, make them left-aligned text only. Flush left text is much easier to read than justified text. Here, this is right-aligned text. Font size, use a 14-point font minimum. Research shows that actively increases scores. White space, leave up to 50% of the page blank. Generous space lowers test anxiety. And wording, keep sentences short, simple, and structured like standard human speech. Good design is going to reduce anxiety, improve accessibility, and get you a fair assessment that measures what you're trying to measure. All right, great work. That is chapter 15. Good stuff.